Hello, welcome to lecture 3. We're going to talk now about DTensor MapMol backwards. So for context, whenever you have a MapMol A, MapMol B in the forwards, to calculate the backwards, you have these formulas. The two things I want to call out are, one, we're going to take the transpose of the inputs, and two, we're going to swap the order of the MapMol depending on if we're calculating the gradient with respect to A or B. Okay, so let's look back at our code. So what we've done is we've modified our code so that now it takes in two inputs, x and y, both of which are 2 by 2 detensors sharded by columns. We've kept our compiled function the same, but we've modified our calling code to call.sum.backward to activate the backwards pass. And we've run it here, nothing too interesting. But if we take a look at the AOT joint graph of the TL parse, there's some interesting stuff. So for those unfamiliar with joint graph, a joint graph calculates both the forward and the backwards in one go. It takes in primals, which is the inputs to your compiled region, as well as the tangents, which are the vectors coming back from backpropagation. In this case, it's coming back from the loss.backward call. So if you look here, we're doing an all gather of primals 1, and then we're mapmoling it with primals 2. So this is very, very similar to the previous lecture, where we are effectively changing the placement type to replicate, and then we're doing mapmol to get these to get a DTensor that's sharded on columns. Here we're calling permute. What permute does is it swaps dimensions. In this case, we're swapping 1 and 0. Another way to describe this is transpose. So permute is effectively primals 1, which is x transpose. So you can think about permute as x transpose. Where does permute flow? Permute flows into this mapmol, where we are doing permute mapmol cat1. What is cat1? Cat1 is tangents 1, which is our tangent gradient, all gathered, and then all gathered into a matrix of size 2 by 2. And so going back to what this mapmol 1 is, this mapmol 1 is x transpose multiplied by g, which is effectively this. Now if we look at mapmol 2, we have g mapmol permute 1, which is y transpose. And so you can see here that that is equivalent to this. And then correspondingly, you can see that mapmol 2 corresponds with the gradient for the first input, which is x, and mapmol 1 corresponds to the gradient of the second input, which is y. So hopefully this gives you a quick overview of how backwards is working with DTensors. As you can see, DTensor is hiding a lot of the complexity under the hood. As a user, you're just calling functions as if they are plain tensors, and DTensor is handling all of the collective operations behind the scenes.